Hello students. So in this video we are going to discuss about chemistry of carbon and nitrogen. This is a chapter. So now let us discuss about the carbon element first. So students, what is atomic number of carbon? Atomic number of carbon is 6. And is it a metal or non-metal? Carbon is a non-metal. So what is so speciality about carbon? Carbon's electronic configuration is 2s to 2p2. It has 4 electrons in its valence shell, and these 4 electrons can form 4 strong sigma bonds. And not only that students, carbon can form multiple bonds. So the speciality about carbon is the element carbon is called as element of life. Why? Because all we are made up of, all the living things, everything are made up of carbon only. Not only living things students, majority of the useful compounds are coming from carbon only. So our life is carbon based life. So that's why carbon is a special element. So what makes carbon so special, which is the reason for all the life forms on our planet Earth. So we'll discuss in this discussion in this chapter called as carbon and nitrogen. So in this video students, we'll stick to this physical properties, allotropic forms of carbon. So carbon is a chemical element with symbol C, atomic number 6. And it's a non-metallic element, tetravalent element. Why? What is the meaning of tetravalent? Its valency is 4. There are 4 half-filled orbitals are there in the valence shell of carbon, all ready to bond. It can form 4 single bonds, it can form double bonds, triple bonds, everything. Carbon can form n number of bonds. So that's why we have these many possibilities. Carbon is one of the few elements known since antiquity. From the ancient times, from the olden times, carbon is the one of the element which is known. Why? Because if you burn anything, what do we get students? We get a carbon black. Yes or no? So that's what the introduction. Next, occurrence of carbon. Like occurrence of carbon is where we can find this carbon. Carbon is everywhere. But is it in the purest form? No. It is in the combined form. Sometimes also it is in the purest form students. For example, as an element, carbon occurs in striking variety of forms. Like many varieties of forms like coal, soot, diamond are all pure forms of carbon. For example, coal. What coal is made up of? Majority share of coal is made up of carbon, and there are some impurities like oxygen, hydrogen, nitrogens are there, but major portion is carbon only coming from coal. And diamonds, students, diamonds, what the diamonds are made up of? What is the formula for diamond? Is there any formula? Like, is it any fixed number of carbons? No. Carbon simply bonded with another carbons to large extent. There is no limit. Infinite number of carbons, only carbons. That is diamond. Pure carbon is diamond. So like soot means if you burn, like I said, the black powder, which is the black soot, which is coming from candle or any other kind of kerosene lamps, that is called as soot, student. That is nothing but carbon, pure carbon. And this carbon also occurs extensively in all the living organisms. Yes or no? What we are made up of? We are made up of carbon only. All the hormones, all the vitamins, all the proteins, lipids, nucleic acids, everything, all are carbon compounds only. Even the retina, skin, hair, all are carbon compounds only. So all the living things majorly they are made up of carbon only, students. So this is in the combined state. Carbon is available in n number of forms. That's why the element is carbon is called as element of life. So carbon is the 15th most abundant element in the Earth's crust and the 4th most abundant element in the universe. So by mass after hydrogen, helium and oxygen. It is present in all the forms of carbon based life. In the human body, carbon is the second most abundant element by mass, about 18.5% after oxygen. So students, carbon is everywhere. We are made up of carbon. What we eat is generally made up of carbon only. For example, all the plants, yes or no, fruits, what they are made up of? Starch, all are carbon. So our life is carbon based life. So everything, we're all made up of carbon only. Only carbon means no, not only carbon, carbon compounds. So that is occurrence of carbon, students. So carbons occur in the combined state, like in the compound form. Like only living things are made up of carbon? No, there are many things which are made up of carbon, non-living. So in the combined state, like oxides, carbon dioxide, carbon monoxide, yes or no? The oxides of carbon, it is available in the nature. Carbonates, what is a carbonate? CO3 minus 2 is carbonate. It's like magnesium carbonate, calcium carbonate, limestone. So there is a carbon there. So carbonates, hydrocarbons, a very important one, hydrocarbons. These hydrocarbons are the reason for all the energy, sources, students, as well as not only energy sources, for all the useful things what we rely in our day-to-day life. For example, petrochemicals, what they are made up of? Carbon, hydrocarbons only. That means the compounds containing carbon and hydrogen are called as hydrocarbons. Ointments, cosmetic industry, plastic, synthetic fibers, whatnot, everything, all are hydrocarbons only. They're made up of carbon and hydrogen. Petrol, diesel, kerosene, oils, candle wax, everything, all are hydrocarbons. Alkanes, alkenes, alkynes. There is a separate branch of chemistry only for carbon, that is organic chemistry. You'll study about all these compounds of hydrocarbons in that chapter. Complex compounds with other radicals, also carbon is in combination, which is found in the nature as well as in the natural water also. In the natural water formula is H2O. How it is available in the natural water means, students, carbon dioxide dissolved in water. Of course, the percentage is very less, but it is also available in the dissolved form in natural water. So these are all the forms of carbon which is in the free state, like diamonds, soot, as well as coal, as well as the combined form like carbonates and all the our body compounds which we are all made up of. The carbon is available. So isotopes of carbon. Isotope, what is isotope? Atoms of elements with same atomic number but different mass number. So what is atomic number of carbon? Atomic number of carbon is 6. What is its mass number, students? Carbon's mass number is 12. That means it contains 6 protons and 6 neutrons. That is called as C12 isotope, yes or no? But not only that, carbon is also available in C13 form also. Not only C13, students, it is also available in C14 form also. These are called as isotopes. What do they differ by? Do they differ by any atomic number? No. Do they differ by protons? No. Do they differ by electrons? No. What do they differ by? All these isotopes? They differ by the number of neutrons. C12 contains 6 neutrons, C13 contains 7 neutrons, C14 contains 8 neutrons. That is the difference. So while there is a discussion about, so why do we have this discussion? Any discussion about carbon, definitely we have to include all these C12, C13, C14 isotopes of carbon. So in general, we are talking about carbon dioxide. We are talking about all these compounds we are all made up of. So which carbon we are made up of? C12, C13, C14, students. Major share, 99% is C12 only. Whatever we are talking about carbon, it is about C12 only. But to some extent, C13 also available. Very rarely C14 also possible. C14 is a radioactive isotope, students. Have you heard about carbon dating technique? That means we can easily find the lifetime of the fossils, like dead remains. We can find their lifetime based on this carbon dating technique. That technique is based on carbon 14 isotope. Why? Because carbon 14 isotope has a lifetime. It's a radioactive isotope. It is a lifetime based on the lifetime of carbon 14 in that particular any material, whatever it is. So they can able to identify the lifetime, the life period of that particular matter. So it is used in the carbon dating technique for the prehistoric objects and very olden things also. Its lifetime is, you can see, 5730 years. The carbon 14 life is very important part of the carbon, students, carbon 14, but major 99% is carbon 12 only. So next, chemistry of carbon. So what is the reason behind all these combinations, all these possibilities, all the compounds? We are all also possible, right? Because of carbon. Why? The reason is, more than 200 years, chemists have divided the compounds into two categories. So to study about the nature of carbon, the reasons of carbon, why it is combining, how it is combining, first of all, we need to classify the compounds, right? The whole compounds are classified in two types, students: organic compounds and inorganic compounds. Organic compounds, the very early scientists, they used to say organic compounds as the compounds which are coming from living things are called as organic compounds, and the compounds which are coming from non-living things called as inorganic compounds. Organic coming from organism, a living thing. But that definition is changed later on, that we study in the chemical properties more in detail. So that's how they classified, to understand the chemistry of carbon. So here we have chemistry of carbon is dominated by the following factors. So 4 factors mainly. One is allotropy, second one is catenation, third one is ability to form the multiple bonds, fourth one is isomerism. So in this video, we concentrate on this allotropy property. So what is allotropy? Allotropy means, students, the same element, but it can exist in different physical forms. That is called as allotropy. For example, oxygen. What is oxygen? O, right? How it is exist? It exists as oxygen gas, O2. it can also exist as ozone, O3. Yes or no? They are allotropes. When it comes to carbon, just guess how many forms carbon available. Carbon available in so many forms, students. Mainly there are two forms, students. One form is called as crystalline form, and second one is called as amorphous form. Crystalline means in this arrangement, in these materials, carbon perfectly arranged the crystalline structure. There is a perfect structure between all the carbon atoms, that is called as crystalline forms of carbon. Amorphous means absence of this structure is called as amorphous. So let us see some of the examples. First of all, what is allotropy? The same element, but it can exist in different physical forms. How it can exist in different physical forms? It depends upon the bonding between the carbon atoms. That will be different. The bondings between the carbon atoms are different. If the bondings are different, do the chemical properties differ? No. All the allotropes have same chemical properties. They differ by the physical properties only. Their shape, their size, their taste, their melting points, their boiling points, or all these solubilities. All these factors will change. Their look, their order, everything will change, but chemical properties remains the same, students. So the property by virtue of which an element can exist in more than one form having the same chemical property but different physical properties called as allotropy. Allotropic forms: diamond, graphite, C60 are the crystalline allotropic forms of carbon. Coal, charcoal and lamp black are the amorphous forms of the allotropic forms of the carbon. Crystalline, amorphous means we already have said crystalline means perfect arrangement of carbon atoms. Amorphous means absence of this arrangement. Right. First of all, crystalline forms of carbon. First one is diamond. So what is diamond? We all know diamond is a very expensive rock. Yes or no? Crystal rock. So diamond, it is the purest and the transparent form of carbon. It is found naturally as well as obtained artificially. Yes, we can synthesize artificial diamonds also, students. Why? Because it is coming from carbon. How the diamonds were made? Diamonds were made at the high conditions of temperature and pressure under earth crust. So if you can maintain the temperature, it is possible to make the diamonds. Already they are doing it. Artificial diamonds are there. It is the hardest natural substance known. Yes, carbon, diamond is one of the hardest substance. Why? Because carbon valence is 4. One carbon bonds with 4 carbons, and those 4 carbons again bonds with other carbons, and other carbons again. It's like a complete net arrangement, and all the bonds are sigma bonds. What are sigma? In the coming details, you'll get that point. Also, the bond between carbon and carbon in diamond is sigma bond, very strong bond. That makes the diamond one of the hardest substance, and it is a bad conductor of heat and electricity. That's what I said. It's a very strong bond, so there is no chance for the free movement of electrons. So that's why diamond is a bad conductor of heat and electricity. It is chemically inert. It is not attacked by the acids or bases. Right? Correct. It is. Diamond is not easily reactive, students, because of its perfect arrangement of all these atoms. Chemical inert. In diamond, carbon atoms are arranged in a tetrahedral structure. Each carbon is attached to the 4 other carbon atoms, like I said. So the arrangement is called as tetrahedral. One carbon bonds with 4 carbons. Again, that carbon bonds with remaining 3 carbons. That's complete, structure. So graphite. What is graphite? Graphite, it's a soft, greasy, dark colored solid substance. It's like a grey colored solid. Yes, sir, that is graphite. It leaves a black mark on paper, and it is called black lead or plumbago. So when you write with, where it is used, graphite is a, lead pencils. Yes, sir, when you write, it leaves a dark line. Yes, sir, no, that's what the point says. So that is, it's a good conductor of electricity. Correct. The reason why it leaves a black mark and why it is a good conductor of electricity, the reason is carbon valence is 4. In diamond, all the 4 bonds are sigma bonds, strong bonds. But in graphite, valence is 4. Valence is not changes. But out of 4 bonds, 1 bond is a weak bond in graphite. 3 bonds are strong bonds. 1 bond is weak bond. That weak bond is called as a pi bond. This pi bond is the reason for the conduction of electricity, as well as why it leaves the mark on the paper, because of this pi bond can easily break. So it is also least active, but active than diamond, students. So are not attacked by the dilute acids or bases. In graphite, carbon atoms are arranged in a hexagonal structure. Many hexagon forms of graphite layer, like in graphite, all the carbons are arranged like layer kind of arrangement, and between all the layers there is one pi bond. This pi bond is the reason for the conduction of electricity, which is a weak bond. So it is used in making lead pencils and controlling the nuclear reactions also. Why? Because it's a conductor. It is used as electrodes in the electrochemical reactions like anode, cathode. We use this graphite, as well as a dry lubricant which reduces the friction, which is a dry lubricant, not like a other petrol diesel kind of thing. So that's why that's the uses of graphite. Next, fullerenes. This is a very recent discovery, students. Fullerene, the formula is C60. It's like a ball shaped arrangement of carbon atoms. It's like a football. You know how in a football how there are hexagonal rings as well as pentagonal rings. The same in fullerenes also, the shape is also almost same like that, and they are called as fullerenes because it is named after an architect called as Buckminster Fulleren. He created this, this dome kind of arrangement. He's an architect, so because based on his arrangement of his structure, this C60 is given the name of the fullerene. So they are called as fullerenes, as well as they are also called as buckyballs. Same buckyballs. So fullerene is recently discovered in 1985. Crystalline allotrope of carbon named after the discoverer Buckminster Fuller. Buckminster is an architect. Based on the architect, this compound is given the name. So spherical fullerenes are sometimes called as buckyball. C60 variant is often compared to a typical white and black soccer ball. Like I said, like how the ball looks like, contains hexagonal rings and pentagonal rings. Same, C60 also contains the same. It contains pentagonal and hexagonal rings. Uses. Fullerenes have been extensively used for the biomedical applications. Yes, students, to target target the cells in the body. Mostly these fullerenes are used in the medical industry to cure the cancer also. These fullerenes, nanotubes are used in all this nanotechnology which is recently being developing in the medical field. Buckyballs may be used to store hydrogen also as a fuel tank, and buckyballs are used in making bulletproof vest also. So these are the uses of fullerene, students. Next we have amorphous forms of carbon. What is amorphous form? There is no perfect alignment, there is no perfect structure. First one is coal. Where the coal is found, students? Coal is found based on the dead vegetation which is being buried under the earth crust for millions of years ago. So because of the limited supply of air, slowly they can undergo carbonization, converts into coal. So it is a crude form of the carbon. It has been formed in nature as a result of slow decomposition. It's not a decomposition, it's like carbonization of vegetable matter under the influence of heat, the pressure and the limited supply of air. The coal is formed. Like where the coal is used for the energy sources, or no? And after destructive distillation, we will get different forms of coal like coke, coal tar, coal gas. Each one have different uses. So uses, it is mainly used as a fuel for burning purpose, for the temperature. It is used for the manufacturing of synthetic petrol, coal tar and coke. Like I said, by the destructive distillation, we can make different components. We can separate different components from the coal, and they have different uses. Coke is used as a reducing agent for metallurgical purposes. Coal tar is used many uses. Naphthalene balls, bituminous roads, all are made from this coal tar. Many uses are there, students. And synthetic petrol also. Yeah, ultimately what is petrol? Petrol is also hydrocarbon. So we can also synthesize petrol from this coal. Next we have charcoal. Charcoal is also a kind of coal, and it is obtained by burning any carbonous matter. Any carbonous matter means a matter which is made up of carbon. Of course, majority it is coming from wood, by burning wood, by burning sugar, or by burning any other forms of carbon life. Matter like wood in the limited supply of air. It is a various forms such as wood charcoal, sugar charcoal, animal charcoal. Like by burning all these forms, we can get that particular type of charcoal. Sugar charcoal is the purest amorphous form of carbon. Like if you burn the sugar to very high level, what will happen, students? You will leave a black color. Yes or no? Ultimately you will get a black powder kind of which is stick to that vessel. That is nothing but a pure charcoal, pure carbon. That is uses. It is used in the removing offensive odor from the air. Odor means a smell, bad kind of smell, and it is also used as a decolorizing agent also. It is used in the treatment of drinking water after chlorination, as it absorbs excess of chlorine. So chlorine is used as a disinfectant to kill the germs. So but if it is excess of chlorine is there, chlorine is also poisonous in nature. To remove that excess chlorine, this charcoal is used, students, and as well as charcoal is a best purifier also. So it adsorbs poisonous gas. Adsorbing means these gases will stick to this surface of the charcoal. So that is all about charcoal. Next, lamp black or carbon black or soot. Like I said, if you burn anything at the top of the flame, you'll get a black powdery fumes kind of thing, right? If you keep your hand on the top of that, the black coating will appear on the hand. Otherwise, sometimes we will do the puja also. Yes or no? In the puja room, you can see the upper layer is completely coated with black. So what is that? If you scratch it, you'll get a black powder. That is nothing but lamp black or soot. That is also a pure carbon only. But is there any perfect structure? No, it's a completely amorphous form of carbon. So it is obtained by the carbon containing substances like kerosene, petroleum, etc. in a limited supply of air. These substances, limited supply of means insufficient combustion takes place. That's why we'll get, if it is a complete combustion, we would have get carbon dioxide only. Because of insufficient combustion, we are getting this black soot. These substances yield a large amount of smoke is collected as a soot or lamp black. So what are the uses? It is used in making printing inks. Yes or no? The ink. How do we get that black color? Is because of, have you seen the Xerox? Even the Xeroxes, they use this black powder. Mostly that is lamp black only. Rubber tires, boot polishes, paints and ribbons of typewriters, everything, or wherever the ink purpose, wherever they need the black kind of material, there this lamp black is being in use. So these are all the uses of amorphous and crystalline forms of carbon, students. So these are all the physical behaviors only, but chemical behavior starts from catenation, that we'll discuss in the next video. So I hope you got the clarity, students. So thank you.